Hi everyone, Unit 4, Applications of Derivatives, Subsection 1, Max-Min Problems. Alright, there's 3 learner outcomes for this subsection. The first one, and super important guys, I effectively read a problem several times before deciding the best course of action. I can use derivatives to find max-min value of a function. I know that the quantity to be maximized or minimized must be a function, and I can find a way to describe that function. So basically that's making an equation out of this. So part 1, number problems. We did max-min problems in Math 20. We used to have to complete the square and find the vertex. It was all a very big process. Using derivatives, we can do that a lot quicker. Now, I want you guys to look at this graph here. Okay? If I want the maximum or minimum value of these curves, that would be right there or right here. Now, the interesting thing is, at those points, look, the tangent line looks like this. Okay? The tangent lines are horizontal lines, which means they have a slope of 0. So remember, the slope of the tangent line is the derivative, or the value of the derivative. Okay, so if we just kind of read over here, okay, max-min value of a function can be easily seen from a graph. It's the vertex. The graph of f of x and g of x are functions that have maximum and minimum values. Note that the slope and hence the derivative of a max-minimum is always 0. Okay, when we want to find the max minimum, okay, the quantity becomes our function. Then we find the equation of that function. Then we take its derivative, set it equal to 0. This will tell us where the maximum and minimum values occur. Okay, with this knowledge, we can determine what the maximum or minimum value is. Right? We find the x, then we can find the y coordinate. Okay, so let's have a look at some of these. I'm going to have to write small. I didn't leave myself a lot of space, but that's okay. So, number 1, find 2 positive numbers whose sum is 15 and whose product is a maximum. Alright, so if we start with the product part. So product equals, let's just say it's x and y, 2 numbers. Okay, the problem is we've got 3 variables there. That's why I have to give you that first part, the find 2 positive numbers whose sum is 15. So we go x plus y equals 15. Okay, now we can solve for one of the variables. So it doesn't matter which, so let's solve for x. So x equals 15 minus y. So we can substitute that in for x over here. So we get 15 minus y times y. Now, I could differentiate right from here using product rule, but sometimes what you're going to find is it's a lot easier just to distribute, and then we can use power law instead of product rule. All right, so there's our product. So now we're going to take the derivative of the product with respect to y. So that's either dp dy or just p prime is fine. Okay, so the derivative of this is just 15 minus 2y. Now I know last unit we did implicit differentiation and you had to go y prime after this, but because we're finding the derivative of p with respect to y, really y prime in this case is just 1, so we don't have to worry about it. Okay, kind of a difficult concept, but just go with it and trust me. Alright, so we have this. Now remember, once we've taken the derivative, we want the derivative to be 0 because we want that tangent line to be at a maximum or minimum. Now, one of the problems we're going to have is, this one not so much, but later on, we're going to have a maximum or a minimum in the same problem, and we're going to end up with 2 answers for the derivative. We just have to interpret what those are, whether it's the max or the min. For right now, though, if we set the derivative equal to 0, because, again, the slope of the tangent line at a max or a min is 0. Okay, so 15 minus 2y. So then 2y equals 15. So then y equals 15 over 2, or a 7.5. Now obviously the 15 over 2 is better, but we're not going to be too fussy about this part. Okay, so if y is 15 halves, or 7.5, then we go back to here, so x equals 15 minus 7.5. Oh, look, 15 minus 7.5 is just 7.5, or 15 halves again. Okay, so we need to find the two positive numbers. So y was 7.5, x was 7.5. I guess we should use the 15 halves. Okay, so the two numbers are 15 halves and 15 halves. Now, hopefully you remember back from Math 20, the best possible shape is a square. Okay, so we have a square here, so that's going to have the minimum surface area, or minimum perimeter, with the maximum area. Number 2, find two numbers whose difference is 100 and whose product is a minimum. So again, we kind of figured out from last time that we have to do that one little formula, two numbers whose difference is 100. So that's going to be x minus y equals 100. And then the product, again, is x times y. So this time, let's move the y over. So we're going to get x minus 100 equals y. Hopefully you saw how I did that. So plus y, and then that goes over to this side, and then minus 100 from that side. All right, so product then is equal to x times the y is x minus 100. Again, we can use product rule if we really wanted, but power rule is better. Well, not better, just faster. Okay, so there's our product. So our product prime, our derivative, is 2x minus 100. Okay, so we want the derivative to equal 0. That's where we get a maximum or minimum. So 2x minus 100, so 100 equals 2x, divided by 2, divided by 2. So x equals 50. Okay, so then we go back up to here. Okay, and x minus 50 equals, well, that was silly. X minus 100 equals y, so 50 minus 100 equals y. Sorry, okay, and then 50 minus 100 is negative 50. Okay, so there's our y value, so the two numbers are 50 and negative 50. The two numbers are 50 and negative 50. So that is going to be the best numbers whose difference is 100, right? 50 minus negative 50 equals 100. Okay, and the product will be a minimum. Okay, awesome. All right, number 3. So find two positive numbers whose product is 108, and the sum of the first number plus 3 times the second is a minimum. Okay, so this time this is a little bit different. The product is 108. So 108 equals x times y. And then, okay, the sum is a minimum. Okay, so that we need a sum equation. So sum equals, okay, the first number, so let's call that x, plus 3 times the second. So plus 3 times the second will be 3y. So what we're going to do is we're going to take the derivative of this function, the s function, okay, and find out our value. Again, we have two variables in here. We don't like that, so we're going to solve. Now look, we have a choice. I can solve for x or I can solve for y. It really doesn't matter. But if I solve for x, then I don't have to worry about the timesing it by 3. Okay, so I'm going to solve for x here. So x equals 108 divided by y. Okay, that makes my sum 108 divided by y plus 3y. Now, oh, sorry, I need to do that a lot today. That's all right. Now, before we take the derivative of this, let's write this better. Remember, we always write a y on the bottom as 108 y to the negative 1 plus 3y, and now we're going to differentiate. So s prime equals, all right, so the negative comes down. So we get negative 108 y to the negative 2 plus 3. All right, the derivative of 3y is just 3. All right, so we set our derivative equal to 0 because we want that max min. So that's negative 108. And then the y to the negative 2 is just y squared on the bottom plus 3. And this whole thing is negative, so you can just move over. So 108 over y squared equals 3. All right, we can switch those two to get, so 108 divided by 3, that is 36. So 36 equals y squared. So then y equals plus or minus 6. Now, in this case, it does say two positive numbers. So that means y has to be plus 6. It can't be the negative 6. So the negative is extraneous, so this y equals 6. Okay, awesome. Then we go back over here. X equals 108 divided by 6. Well, 108 divided by 6 is 18. Awesome. Okay, so the two numbers then are 18 and 6. Now, does that make sense to they multiply to 108? Absolutely. Sum of the first plus 3 times the second is a minimum. Yep. Okay, so the numbers are 6 and 18. Numbers are 6 and 18. Right, we should answer these with a word problem, or we should answer word problems with a sentence. That's why we're always going to put those there. All right, number 4. Find two positive numbers whose sum is 30, and the square of one number plus twice the square of the other is. So a minimum, maximum. Interesting. All right, so let's have a look at this. So two positive numbers whose sum is 30. So we're going to have x plus y equals 30. Okay, and then let's see, this we're talking about the sum, and the square of one plus the other is, so we're adding again, so that's the sum is the square of one number, so x squared, plus twice the square of the other, so 2y squared. And that's supposed to be a minimum. So let's see how this plays out. Again, we have a choice. I can solve for x or I can solve for y. If we solve for y, we're going to have a 2y squared. So that's going to be, it's fine. It'll just be a little awkward. But let's choose to solve for the x because we only have to square it then. We don't have to multiply it by the 2. So x equals 30 minus y. Okay, so then our sum will be 30 minus y squared plus 2y squared. Okay, awesome. Now, I can distribute that, or I can just take the, use all of our rules to find the derivative. So why don't we do that? Because I made you learn all those rules for a purpose. So s prime equals, okay, so the 2 comes down to 30 minus y to the 1, and then we have to take the chain rule. So the derivative of the inside is negative 1, okay, plus 4y. All right, that's not too big of a deal. So let's see. Negative 2 times 30 minus y plus 4y. Okay, so that's going to be negative 60 plus 2y plus 4y. So s prime equals negative 60 plus 6y. So we set the derivative equal to 0, and we get 0 equals negative 60 plus 6y. So the 60 comes across, so 60 equals 6y. So divide by 6, y equals 10. Awesome. And then, of course, we move that over to here, so x equals 30 minus 10, so x equals 20. So the two numbers are 10 and 20. Two numbers are 10 and 20. Now, awesome. Look at this next part, though. It says, ooh, what if we want them to be a maximum? Now, the funny story here is if we have a look at this equation here, so the original sum equation, okay, this guy here, that's going to be a negative y squared, which is positive y squared. So this sum equation is going to be 3y squared plus a whole bunch of stuff. Either way, this guy, a 3y squared, is going to look like this. It'll have a minimum, but it won't have a maximum. So there's something interesting or weird going on here. This equation does not have a maximum except for this part here, two positive numbers. Okay, the idea is as the numbers, if they're both negative, they'll just keep going on and on and on and up. So, but we have these restrictions. So what's going to happen here, everyone, is for a weird question like this, we're bound by certain things. So what we're going to do is we're going to set up the extreme values for us. So if we say two positive numbers, okay, and we figured out that the minimum is 10 and 20, the maximum would have to be, okay, what are the things that could add to 30? And let's count 0 as positive. So it could be x equals 0, y equals 30. Okay, that would be the extreme end of one of the parabolas. Okay, or we could have x equals 30 or y equals 0, right? Because that's the extreme end of the two positive numbers whose sum is 30. And now one of these will give us a maximum in terms of the context of this question. Again, we go back to this parabola. It doesn't have a maximum. It's going to keep on going forever. But in the context of our question, we stop where the sum is 30. Now look, because remember, you could have something like 31 and negative 1. That adds to 30, but that's not two positive numbers anymore. That's a negative number and a positive number. So that's not going to work, obviously. So we take our two extreme ends and we see which one is bigger. So remember, our sum equation was x squared plus 2y squared. Okay, well, if x is 0, you get 0 squared plus 2 times 30 squared. Well, that one gives us a sum of 1800. Okay, what about the other one? So if x is 30, so we get 30 squared plus 2 times 0 squared. Well, that's only 900. Okay, so for us to have a maximum, okay, well, the maximum number best I can do is 1800, and that's when x is 0 and y is 30. So the two numbers, we get a max at x is 0 and y is 30. It's weird we don't use derivatives for this particular one because, again, the parabola itself doesn't have a maximum just by the context of our question. I know it's confusing, but bear with it, and feel free to ask me or Google Hangout me, and we'll talk more about it if you think you need. It's not a really big deal. Most of the questions are going to be taking the derivative. Thanks so much, guys. Talk to you later.